Hi, this is our Physitech Electronics 16-bit adder subtractor using 4-bit adders. This model number was PHY-258. We have designed this trainer as per the J2 Hyderabad syllabus. This is an user-friendly trainer kit. We can easily perform 16-bit adder and subtractor by using this trainer. The students can get more knowledge by connecting the circuit diagram to this trainer manual. Here there is a manual for 16-bit adder and subtractor. Here the aim and apparatus and theory about this. Here is our circuit diagram. By using 4-bit parallel adders, we can construct the 16-bit adder and as subtractor. In this only we can perform the both adder and subtractor operation. Now looking to our trainer kit, there is a 4-bit parallel adder, that is the 7483 IC. Here the 12th pin was ground and 5th one was 5 volts. We have connected each IC ground and supply. Here is the XR gates. Is the logic low level and high level. This is logic indicator in the right side, that is the LEDs. In left side we have the logic outputs, that is variable switches. It is 0, 2 and 1 level. In 16-bit adder and subtractor, there is a 16-bit data as input, that is two data. One is A0 to A15, that is the one data, and another data is B, that is B0 to B15. Here looking at the IC, here 10th and 8th, 3 and 1 pin, that is the first data A0 to A3, and the second data B0 to B3, that is the 11th pin, 7th pin, 4th pin and B3 in the 16th pin. In that, in IC there is a 4 outputs, that is E0 to E3, that is the E0 is 9th pin and E1 is the 6th pin, E2 is the 2nd pin and E3 is the 15th one. These 4 outputs is connected to our logic indicators. From that first data, that is A0 to A3 is connected to our logic output switches. A0 to switches. A1 to A1. Here the indicators A0 to A3 and B0 to B3. Same as B3 to B7 and same as A8 to A15 up to 16 plus 16, 30 as input. So we require A as 16 inputs, that is A0 to A3 is present in first adder, and here is A4 to A7, here is A8 to A11, here is the A12 to A15. So these all data, first data to connect the switches corresponding these levels A0 to A4 and A4 to A8 and A8 to A11 and A12 to A15. After connecting the A data A0 to A15, now enter data, that is B0 to B15. Here we are looking at first IC, there is B0 to B1, B2 and B3. Here is B4, B5, B6, B7. Then third IC B8 to B11 and finally B12 to B15. These are also connected to the output of the XR gate. Here is B0 to B3 and B4 to B7, B8 to B11 and B12 to B15. Input A data is connected directly to the switches, but the B of the IC we are given to the XR gate outputs like this. This is B0, B0 to B0, B1 to this B2, B2 B, B3 B3. Similarly, up to we have connected the B15 to parallel remaining ICs. After connecting the B data B0 to B15. Here in each IC there is no power supply as inbuilt. So the 12th pin was ground and 5th pin was supply. So we must apply the supply and ground as well as. Ground means to give the low level and supply means to give the high level of our trainer. Here 12 pin as the ground is connected to the ground is here provided. Same as remaining grounds of IC. Here third with parallel ladder to short the fourth ground by using multiple. Here is the 12th pin of the 14th adder to complete ground. Same as supply to short the supply pin on all 4-bit adders, that is the 5th pin, and given to the high level. Here we are given to the XOR gate output to the B data of our ICs. Here there is two inputs of the XOR gate, that is one input of that is the second input of the all XOR gates are shorted. So take one patch card to connect the in low level. Similarly, the second input of the XOR gate is common, that is connected to the low. We are given the individually, or we have to short the common to all and given to the low level. So the second data is shorted to 4 XOR gates of 4 sections and given to the low level. Now one of the input is common to all XOR gates. The first input of the XOR gate is B0 to B3 and B4 to B7 and B8 to B11, B12 to B15. These are given to the input logic switches. This is the B0, B1 up to B15. We have to connect the data.
Connected with C in and C out. C in directly connected to XOR gate input. C out connected with next stage of 4-bit parallel adder. Connect C in. Next C out is connected to C in. Last stage of C out connected with XOR gate input. XOR gate output is connected to LED. E out to E3 is connected to output LEDs. E0 to E15 connect to LEDs.
Now the XOR gate output. This is B out. Take one patch card. From that, the first input of the XOR gate, that is the C in, that is C out. So this is the C out, this is the B out. Take another patch card. Take one patch card. from the first adder, that is the C-in pin, to take multiple patch cord to and this one is connected to the low level. So we take the one patch cord from the C-in and to the low level, and one of the XOR gate input, that is the common to the all XOR gates, that is also connected to the low level. So these two patch cords are given to the low level for performing adder operation. So if you plug out these two patch cords and plug in high level, then our circuit will perform subtractor operation. So in subtraction we need bar out, that is XOR gate output. We connect the bar out to the LED. So if you do the adder operation, we acquire carry, that is this one. We have to connect this LED. So if you plug out these two and connect to the low for adder operation. Now switch on your power source. Before you switch on your power source, keep all logic outputs to the 0. By setting all switches in 0, now switch on your power source. Initially they are all zeros, so the output also 0. Now I change the data A0 to A7 1. So these are 8 inputs are ones and remaining also are 0. So the output will be recording as 8. Now I plug out to low level and perform to subtractor operation, put in high level. In the data A0 to A4 put 4 ones, remaining all of A data will be 0. Same as B data, B0 to B4 also put 1. So we perform the adder, so we acquire carry.
This is MSB bit, this is LSB bit. MSB bit, LSB bit. 4 ones. A data is first 4 ones and B data first 4 ones. Adding 0, 4, 1, 1, 0, carry 1, 1, carry 1, 1, carry 1.
Initially our two data A and B, they both are zeros. There is no output. Why? Because we are given all zeros, the output also 0. There is no carry also. Now I change the data. A0 to A3 gives ones. So the output of the will 4 ones. Why? Because LSB of the A data is 4 ones. Remaining all are 0. So at present we are only 4 ones. Now I change the B data, B0 to B3, also 1. So look at here, the data was 0, 1, 1, 1, 1. Our data is 12 zeros and 4 ones for A data. Similarly, B also 12 zeros and 4 ones. So this is the adder operation for that, for this condition. Now put the A data all high, that is 1. Put the B data all zeros. (16 ones and 16 zeros). That is no carry. Now I change the data. Now I change the data B0 to 0 to 1. Just observe our logic indicators. So the A data is from the A0 to A15 is all ones, and B is 1, B0 is 1, that is the LSB bit. So consider LSB to MSB, by adding they all becomes to carry out the most significant bit, that is we are observing C out. This is the adder operation. Now I change the all B data will be high. And put the A data to 0. Now A data is all zeros and B data is all ones. So the 16 outputs, 16 ones, that is 16 ones in output. There is no carry. Why? Because our A data will be 0. If I change the data in A, that is A0. So similarly in previous condition, so adding the all LSB to MSB bits, we can observe only, we can get the carry only. Now I plug out these two wires, that is the one of the cascade common input of the XOR gate and the CIN to the low level to high level to perform the subtractor operation. And one more point, we plug out the C out and connect to the B out, that is the XOR gate output. Initially all are zeros, so the output also 0. Now I change the data A0 to A7, that is ones. Remaining all are 0. So the only A data will comes at our output side. There is no borrow. If I change the data B, so here A0 to A7 is 1 and also B0 to B7 is also 1. So the output is 0. Now I change the data. A all in A0 to A15 is 0 and A0 to A7 is also 0. Now the B data B0 to B7 is 1 and B Now I change the data. A0 to A15 is all zeros and B data B0 to B15 is all ones. So looking at our logic indicator, there is a last significant, that is the 1, and the borrow out 1. Why? Because 0 and 1 all 0, this is also 1. So 0 and 1, that is last significant 0 to 1 and now I give the data A0 to A15 is all zeros and B data B0 to B15 is 1s, that is 0 minus 1. To subtract the 0 minus 1, the output will be 1 with borrow 1. We can observe that logic indicators. This is the LSB, that is the output of the 0 minus 1 with borrow out 1. Similarly, we have to perform the different datas and observe our logic indicators. When we have performed the subtractor, we plug out these in a high level. When we have to perform the adder operation, we plug out these two patch cards and put in the low level for adder operation. Thank you.